predictability. The milkman, the paperboy, evening TV. Did I get delivered here? Somebody tell me, please. This whole world's confusing me.
Guys, unfortunately, I have to close the company.
But why? There's gotta be some way. Maybe our calculations are wrong.
Our calculations are perfect. They're perfect, you hear me?
There's nothing wrong with the second look at them.
No, there's nothing wrong. Look, see? They're perfect. Perfectly fine.
Dr. Thorne, you don't understand. We have to save the company. Corny, my dear friend, he needs this medicine the company makes.
I can't stop thinking about it. How much longer will it take to cure this? Just to cure it, 'cause I can't ignore it. If it's
No, Corny. I have to save the company. Eureka!
Wait, but please keep your clothes on. Holly! What are you doing in here?
Saving the company.
What do you mean?
Exactly what I said. I'm saving the company.
How? How did you do it?
It's simple composition stoichiometry, you see.
So what's the answer?
You see, we didn't use enough water. We only used 8.19 grams of water, but really we need double that. And if we use double that, then instead of ending up with 65.1 grams of our compound, we end up with 130 grams.
Holly, you did it!
Dr. Helm!
No time. I did it, Corny. I saved the company. Here's your medicine.
Hey, I'm sorry, Holly. It's too late for me.
No, Corny, no, it isn't.
Just know, I always...
No, Corny.
Nah, I'm just kidding, I'm fine.
Hello, I'm Dr. Holly Helms, and here's the math behind our video, Project X. So here is our chemical formula, with X being what we wanted, what we had to pay the most money for, and we wanted this as our product, which we sold as a medicine to Cornelius. So given this, and given that our molar mass of element X is 275 grams, we had 0.4546 moles of water and 0.4545 moles of element X. Now, this would be fine and dandy if we had a 1-to-1 ratio, but instead we have a 1-to-2 ratio. So we in fact need actually 2 times however much we had of element X in moles of water. And so, given stoichiometry, we can find out that with water as our limiting reagent, we ended up with 0.227 moles of our ionic bond. But this does not compute well because we are only using half of the X we need, or half of the X that we have and pay for. Instead, I proposed that we would use 0.910 moles of water, and with this we end up with a theoretical yield of 0.4545 moles of our X oxide. And this works much better because instead of ending up with about 70 grams theoretically, we ended up with 140 grams theoretically, and with a production of 92.7% of the theoretical yield, that computes to 130 grams. This means that given the price of our X oxide is okay,
Yeah,
you're gonna edit it, right?
Yeah. Wait, let me make sure it's still recording. Okay.
Now we'll talk about how that difference computes to money. The first time around, our profits were $356,052. Given that the price of X oxide is $416.73, but the amount we had to pay for element X was $52.19. With the proposed change that I had, the company will bring in profits each week of $711,986. This is a much better work, and it will save the company. If we count the profits lost from 6 weeks of what the difference between these two was, over 6 weeks we lost about $2,135,604. Over 3 weeks, our company will pull out of this and continue to make up for having made up for the profit loss, we will make up a whole new profit. And that is why we created the video Project X. I hope you can work with that. That was pretty bad. Do you want me to try it again?
Oh no, that's fine, bro.